Good morning, students. Welcome back to the class once again. And I hope that this summer break was enjoyable to you all. Yes, considering this lockdown and the entire pandemic scenario, but still, excluding those things, I hope that you are safe and had a lot of creative work done during this time. So now once again back to the after the break. So once again I welcome you back to the chemistry class, and of course once again welcome you to the world of atomic structure. If you remember, then definitely that before the vacation the first lecture or the first class of atomic structure was taken. And I hope that with the first lecture nobody had any queries regarding that one, because that the first lecture was more about an introduction to this atomic structure chapter, that what we are going to do in this chapter, what we are going to read, and everything was done or dealt with a discovery or with from which time it came into existence, and how the theory were proposed, who discovered what the different components of the atoms and all the stuff were discussed. So it was a very short, it was a very brief discussion which were done. Now today, in this class, today we will discuss about, once again I'll do a short revision. Revision means regarding the point where we stopped in the previous class. So I'll start from that particular point, and we'll continue then from there. And today the discussion will be a bit elaborative, a bit descriptive, and of course, and definitely this elaborative descriptive means a detailed mode of discussion, a detailed discussion about based on your class, of course, based on the standard 9, a detailed discussion about atomic structure, or the different, or from the points, from the portion which were discussed in the previous class, from there. Now moving on to that, as we know that you remember that we stopped regarding those different particles of an atom. The first was Sir Joseph John Thompson, J.J. Thompson, and he discovered electrons in the year 1897. And there he goes, Mr. Sir Joseph John Thompson. The next we are having the Eugen Goldstein. We are having Eugen Goldstein in 1896, followed by Ernst Rutherford in 1909. And he discovered the protons. Ernst Rutherford started with Goldstein, followed by Ernst Rutherford. He discovered the protons came into existence. So there is Eugen Goldstein, and there is the next person is Ernst Rutherford. The next particle, that was Sir James Chadwick in the year 1932. He discovered neutrons, and there is Mr. James Chadwick, Sir James Chadwick. Okay. Now these things we already discussed in the previous class, and as I said that I will be discussing, once again I'll start from that point from where we left. Okay. Now continuing with this, the electrons, the protons, and the neutrons, we will start today that how the discovery of the electrons were made. The first experiment that Sir J.J. Thompson did was cathode ray experiment. From his experiment, the cathode ray experiment, he discovered the electrons. From his experiment, he discovered electrons. Now, This discovery was not planned. It's not that Sir J.J. Thompson was attempting to prove, was attempting to what should I say? Yes, definitely prove that atoms are divisible and it contains electrons. It's not that Sir Thompson was having a predefined, pre-notioned concept or idea that atoms are divisible and atoms can consist of different particles also. He had till that time he didn't have so much of idea. But after the experiment, he came up with a different conclusion. His attempt was to study the properties, the cathode ray experimental setup, as the name suggests. He started the experiment because he aimed to study the properties of cathode rays. That was the main primary aim. The primary aim of the experiment was to study the properties of cathode rays. That was the primary objective. How? By this way. He made an experimental setup. There was a tube, as you can say, a discharge tube, and he connected with two terminals, the positive terminal and a negative terminal. That is, the positive terminal is connected of the battery is having the positive end, and cathode is connected to the negative end. So cathode becomes negative and anode becomes positive. As per the electrical guidelines or electrical rules, laws, character of the atoms or electrons, the cathode is actually negatively charged since it's connected to the negative terminal of the battery, and anode is positively charged because it's connected to the positive terminal of the battery. Now, as the experiment started, after a certain point of time, as the experiment started, the cathode started to emit certain radiations. No problem. Then definitely those radiations is getting accepted or absorbed by the anode which is present there. Okay? Now by the anode which is present there. Now this experimental setup, after a certain point of time, Sir Thompson noticed that the cathode rays are getting deflected. When he is bringing a positively charged plate near the cathode ray discharge tube. Near the discharge tube, when Sir Thompson was bringing a charged plate, that means a positively charged plate, when he's bringing that one, along with the negatively charged present which is also present, the rays started to get deflected or it started to get attracted towards the positively charged plate. Positively charged plate, a deflection. So once it's written cathode ray without electric field, and the next one is cathode ray with electric field. So electric field. So when this cathode rays are being exposed to electric fields, then cathode rays were showing deflections. So it's getting attracted towards the positively charged plate, which clearly shows that cathode rays are negative in charge. Since it's getting attracted, so the cathode rays must contain certain things which are getting attracted or deflected, attracted towards the positive plate. Okay. Now, along with this, he also noticed that cathode rays cathode rays are creating a green fluorescence on the on the plate or on the screen at which is present behind the anode terminal. Now this is the one of the outcomes, but before going to the outcome we need to know certain properties of the cathode rays. The first is cathode rays, this travel in straight line from cathode to anode. The next, they cause greenish yellow fluorescence on the soda glass screen. Greenish yellow fluorescence on the soda glass screen. That is, if you remember, just now you have seen that the first diagram, the back side of the anode is painted or coated green to make to realize or to make the people understand that yes, cathode rays are greenish in color. It's a greenish yellow fluorescence, its color, and it is helping us and other workers, to realize, to see that yes, it's green in color and it's due to the cathode rays. The next, it's showing deflection in the presence of field. We have already seen that. Cathode rays penetrate through matter. That's another property. Cathode rays, they are having the capability, that is, to penetrate through the matter. So it's not that cathode rays can be restricted by normal substances. Okay. The next is, they produce shadow of the object which is placed in between the path of its movement. That is, cathode rays are having particle character. And hence that reason, since it's having a particle character, so this proves the shadow of the of any object which is being kept over there. It is showing the properties of the cathode rays. Now these properties, as you can see over here, as you can see the shadow of the object which has been kept in the middle. There's a fan-like thing which is there, and that's creating a shadow on the screen at the back side. And also along with the screen, there's the gas or the substance is greenish yellow in color. So greenish yellow, cathode rays greenish yellow in color, that's acceptable, and it's the substance shadow which is being kept over there. Now cathode rays produce greenish yellow fluorescence. So that's another statement that cathode rays produce showing your greenish yellow fluorescence. The next properties of electrons. The first is, electrons are of all sources are alike. That means, as I discussed in the previous class, that all substances are different, and these substances, they need to they all are different and are identical in nature. So whoever the substances, whether it's iron, whether it's copper, whether it's sodium chloride, whatever, the examples of these clips, the electrons, they actually of one substance, electrons are there. In another substance, iron and sodium. So the electrons of sodium and electrons of iron are actually the same, no difference. So electrons from whoever the source becomes unimportant, whoever the person is can accept the electrons. So electrons doesn't become acceptable. The next is, electrons are having unit negative charge. The next, they're extremely small. The radius is of the order of 10 to the minus 15 meters. The next point which is are having mass is a mass of hydrogen atom is the mass of electron. So the mass of an electron, one electron system. So the mass of one electron is 1 by 1837 times the mass of hydrogen atom. So hydrogen being the lightest, electrons are almost 1,000 times less lighter than this 1837. The next, the particles that are the particles, that's electrons, they get attracted towards the positive plate and the negative plate. They are attracted towards the positive plate. Now the properties of anode. Anode, they travel in straight line. Another one, they are positively charged particles, and they show deflection in the presence of electric and magnetic fields. Anode rays also penetrate through matter. Anode rays also penetrate through matter. So the penetrating power is there. The next is anode rays. They produce fluorescence on zinc sulfide screen. So anode rays, they are producing anode rays. They are producing the fluorescence on zinc sulfide. The next is properties of protons. Properties of protons, they are having the same mass that of hydrogen atom, because as we know that hydrogen atom is having 1 electron and 1 proton and no neutron. So electrons are the lightest, so maximum mass is basically due to hydrogen. The next, protons are having unit positive charge. The next, they are extremely small. Protons are extremely small in radius. Protons are actually 1 by 1837 times the mass of an electron and resides in the central part of the atom. So these are the few properties of protons. Protons are deflected towards the cathode plate in an electric field. Why cathode plate? Because cathode is negatively charged, proton is positively charged. So protons get deflected towards the positive plate in an electric field. Neutrons, they are the heaviest particle in an atom. They have no charge. It's a non-chargeable particle. Next, they are extremely small, less than this. Mass of neutron is 16. This one, it's basically as a mass of 1 unit. So the next is neutrons. They remain unaffected in the presence of electric and magnetic fields. Now after this, coming to the next, that's Rutherford's atomic model, though it was previously discussed. So some of the thing we need to discuss once again and in a proper way. So the postulates of Rutherford's atomic model. The first is most of the space inside an atom is empty because the alpha particles passed through the foil without getting deflected. So most of the space inside the atom is empty because the alpha particles going through the gold foil without getting deflected. The next is very few particles were deflected, indicating the positive charge, and the atoms enjoy very little space. The next is we are having the central part is nucleus containing the mass of an atom. The next property, the next postulate of the atomic model was the size of the nucleus, which is very small as compared to the size of an atom. So the size of the nucleus is very small as compared to the size of the atom. It's obvious because the nucleus is at the center. So the size of the nucleus will be very small compared to the size of an atom. Electrons revolve around the nucleus in well-defined orbits. That's another point, that's another postulate of the Rutherford's atomic model. So the first, let's discuss once again that the most of the space of the inside the atom is empty. So he postulated that the atom inside most of the space is empty. Since because most of the alpha particles pass through the gold foil. That was the first. The second is very few particles got deflected, so indicating that the center part is a positive charge, occupying a very little space. The center part is containing the nucleus. It's a very small thing. And the fourth is the size of the nucleus is very small as compared to the size of the atom in comparison. And electrons revolve around the nucleus in well-defined orbits. Now, well-defined orbits are basically energy levels. These are basically one should say it's a staircase. So first, lower the stair is having the minimum energy. The topmost stair is having the highest energy. In that way, the energy levels over here also, it's well-defined orbits. Orbits are basically energy levels. So it's containing energy and in well-defined energy levels. Now, after the postulate of atom is in a whole electrically neutral. So atom is an electrically neutral substance. Now, but these postulates of Rutherford, when it came out, after a certain point of time, these postulates were challenged, and the hypothesis of the Rutherford regarding the atomic model, that was said or proved to be incorrect. It was not correct. Now the question arises, if the atomic model is not correct, what are the defects in the model? What are the defects present in the model? We need to know that. So let's go on. Let's move on to that. What problems are there in the atomic model given by Rutherford? For that, I will make you to discuss this, the problems or the drawbacks of Rutherford's atomic model. You better watch this video. It will be more clear to understand. Sorry.
Explaining the structure of atoms. However, it was not very appropriate theoretically. And why are we saying so? We know that any charged object which revolves in a circular motion gains acceleration gradually. Similarly, if the electron is moving fast in a circular path, then it will also gain acceleration. And on gaining acceleration, it's bound to liberate energy in some form. Now, if it continuously keeps radiating energy, then ultimately all the energy of the electron will get over and it will fall into the nucleus. This would result in high instability of the atom. But wait a second, all these things do not happen in an atom. And how do we know this? Because in nature, all the atoms are stable. That means the hypothesis put forth by Rutherford was also incorrect? Not really. The hypothesis just needed slight modifications.
Now, so I hope it's this video has made you clear that what are the drawbacks Rutherford model has. What problems the Rutherford model had, and as it said that the Rutherford's atomic model was totally not wrong. It needed slight modifications, certain modifications required. And if that modification, instead of totally rejecting one model, if the slight modification can be done, then Rutherford was completely correct. Now those slight modifications was put forward by another one legendary person, yes, And that legendary person was this man. And who is this man? Niels Bohr. Niels Bohr is the man, the legendary man, who put forward these modifications considering the Rutherford's atomic model. And what were his modifications? The first thing he stated that electrons revolving around the nucleus are confined to certain fixed orbits or shells or energy levels, each of them having fixed amount of energy. He said about orbits, if you remember, that what Rutherford said? Rutherford said about orbits. And Niels Bohr is proposing about those orbits. He just renamed those orbits as shells but as energy levels. So the electrons revolving around the nucleus, they are confined. Confined means when they are circulating around the nucleus within those energy levels, they cannot leave that particular energy level, that particular orbit. According to Rutherford, he said that electrons will revolve around the nucleus in energy in particular orbits, that means well-defined paths. But he didn't mention that according to him, after a certain, as from the video we can make it out, that it will lose energy, and automatically what will happen after losing energy? It will collapse. But over here, Niels Bohr just slightly modified and said the electrons will be confined. Confined means they will not leave their particular positions. They will not leave their particular positions when they are just rotating around the nucleus, until and unless external energies or any third thing is external or energies are being supplied. So they will revolve around the nucleus in a fixed orbit, but they are confined over there. What's the next? Electrons revolve around the nucleus, do not lose or gain energy. So electrons revolving over there, they do not lose or gain energy. The next is electrons revolving in a particular orbit jumps to the next orbit after gaining a certain amount of energy. So these were the modifications made by Niels Bohr based on the Rutherford's, or rather considering the Rutherford's atomic model. The fourth is energy shells. What Rutherford didn't do is, Rutherford didn't mention any names to those energy levels or orbits, but Niels Bohr said these energy levels will be named as K, L, M, N, and so on. Or we can also assign as numericals, integer naming. Default as n, and where n starts for 1, 2, 3, and so on. And 1 stands for the first orbit which is closest to the nucleus. N equals 1, it symbolizes, it means that it is the first orbit which is closest to the nucleus. And that corresponds to the energy level or energy shell K. N equals 2, that means the second orbit from the center of the atom, that means from the nucleus, the second orbit which is coming after the first one, that's the second orbit, N equals 2, and that is also having the name L. So based on this, that is the N equals 3 of the third orbit, N equals 4 of the fourth orbit, so 3 means M, third orbit is M, fourth orbit is N, so like that way it goes on. So these were the modifications made by the legendary person Niels Bohr. And now, after that, atoms are stable. What atoms are stable? For that reason, since based on this, so according to Rutherford's conclusions, atom would have been unstable. But atoms are stable, and now that was explained. That was explained by whom? It was explained by Niels Bohr. So let's watch this video. You'll understand the things more clearly.
made by the next legendary scientist in our list called Niels Bohr. He made a few additional explanations to describe the atomic structure. The postulates put forward by Niels Bohr were as follows. Firstly, only certain special orbits called discrete orbits of electrons are allowed inside the atom. Secondly, while revolving in these discrete orbits, the electrons do not radiate energy. Now these points definitely tell us why an atom is so stable. But what exactly are these paths or orbits in which the electrons revolve around the nucleus? Let's understand with an example. Do you know how our solar system is? Yes, it appears somewhat like this. Now here, the sun is stationary at the center while the planets revolve around it. But have you noticed that the planets always revolve in fixed paths? We never find any planet jumping to a different path all of a sudden, right? They always encircle the sun in defined paths. In a similar way, we have the atomic structure. The nucleus acts like the sun located at the center, and the electrons are like planets which revolve in fixed, defined orbitals. These electron orbitals are referred to as shells or energy levels. Now the name energy levels gets us to an important concept. Niels Bohr suggested that the electrons revolving in these orbitals do not radiate energy. Now this is justified when we use the term energy levels, because it indicates that each shell has got a defined energy level. That means when the electrons revolve in these shells, they do not liberate any form of energy. And how do we name these shells to indicate their position? It's simple. Beginning from the one near the nucleus, we name them as the K shell, L shell, M shell, N shell, and so on. Yes, K, L, M, N, and so on. And what if we want to number them? In that case, we use the letter N in lowercase and write them as N equals 1, N equals 2, N equals 3, and so on, beginning from the one next to the nucleus. So we can name them alphabetically, or we can even number them. With all these theories and points known, do we now know the structure of a typical atom completely? The nucleus contains positive protons and the electrons revolving around in fixed orbitals. Is that how an atom is structured? Not really. We still have one more subatomic particle left. And what and where could it be? Let's find that out. It was around the year 1932 when a famous English physicist, Sir James Chadwick, found the third subatomic particle. He found that the particle had a mass almost equivalent to that of the proton. And what about its charge? Astonishingly, it had no charge. Yes, the particle was neutral. The particle was later named as neutron, denoted by the letter N. Thus, now we have the complete design of an atom. In the center lies the nucleus having positively charged protons and neutral neutrons, while the negatively charged electrons revolve in fixed orbitals around the nucleus.
So I hope it's this video has made it's a very interesting, a very beautifully presented video. So after the lecture, this video, I hope it has given you a very clear idea, a very clear concept about regarding the various particles of an atom and the structure of an atom, how the electrons are present in an atom, how they're not stationed at one particular place, they're revolving around the nucleus, and everything very clearly presented, clearly done. And I don't think you should be having any problem or doubts after watching the entire this tutorial. And with this, I conclude today's lecture. So thank you, and stay safe and take care of yourself. Thank you.